Hi, in this video I'm going to show you how this synctest package of testing works in Go. So let me start with an example scenario first. So let's say you have a struct of type cache, and what it has is it has a mutex and a value and a field called expiry at, which means you are storing this cache only for certain amount of time. After that you are no longer storing it. So it has two functions, set and get. So the set will set the value as well as the time, and then get will check if it is expired, then it will not return it, otherwise it will return it. Simple. So let's see how we generally write test for that. So generally the way we write test is we create this cache, or we set it, call the set function, and then we initially call this get function, and of course we will be able to see the expected value, but then we also want to test if it is actually expired or not. And to simulate that expiry, we'll need to do time.sleep here for, let's say, 3 seconds here, because it is for 2 seconds. So after 3 seconds it must be expired. So after 3 seconds we do a c.get and see that it is actually truly expired. The problem here is that here this sleeping is actual 3 seconds, which means in a production environment your testing suite will become slower. It will take much longer time because the waiting times are happening in the actual real world clock. Okay, so the idea is that how about we make the program aware of the fact that this is supposed to be a sleep, but keeping in mind that this is a lower amount of sleep, this is a higher amount of sleep. So this will be executed first and this will come later, but overall it will happen instantly. So this is what the synctest.Run does. Let me show you an example. So synctest.Run. So if you do the same test inside this synctest.Run, and then inside its function you do whatever you wanted to do before. Okay, so you initializing this cache, then you are doing this initial get check, then you really do the time.sleep here. But inside this synctest.Run, all clocks are fake. So here this sleep will no longer be actually going for 3 seconds, it will be instant. But it will keep in mind that this is 2 seconds, this is 3 seconds, which means whatever is related to this, that should happen first, and only then this should be done. Okay, so the relative time, it will be aware of that, but in real world for us it will be instant. Okay, so let me run the first one and see how long it takes. So it's running this test and it will literally sleeping for 3 seconds, so it total takes 3 seconds. But for this new test with synctest.Run, if I run it, it is instant. The test still passes and it is instant. Okay, so this is the first aspect of this synctest package. Basically synctest.Run, inside that the clocks are fake. Okay, there is another package called synctest.Wait. So let me again start with an example. So let's say you have a store struct which stores items and it has a mutex, and we have two functions here, add async and simply getter with items. So here in this add async, we do a go routine, and inside the go routine we call the lock, set it, and then call the unlock. Okay, so assume that lots of go routines are accessing these items. So for them we need to add the items properly and add all of them, which is why there is a lock here, so that all of them actually do it. But uh, let me show you how the testing becomes a pain in such cases. So here this is the test for that. So I initialize a store and then I call 3 times this add async. So add item A, add B, add C. But then we have to ensure that all of these go routines are actually done before we start to check if all the items are there or not. So for that we basically do a small time.sleep. Here in this case it's 100 millisecond, and we basically hope that this is enough. Okay, and then we check, and then yeah, we can check if these items are properly added or not. So the problem with this kind of scenarios is that we never know for sure how much time it will we should set here, and we might end up setting a higher time than we actually need, and then that may cause some flakiness in the test. So if I run it here, it passes, but it takes 0.1 seconds. So to solve this scenario, we have this function in the synctest package called synctest.Wait. So what this does is that it waits until all the Go routines are finished. It basically simulates that scenario, and then you can do whatever checks you wanted to do in such cases. So here, again, you are running this inside the synctest.Run, and here the times are basically the fake clock. So here, once you put this wait function, it will ensure that all Go routines are finished, and so that it is safe to assert. So if I run this, it is running in literally 0 seconds, or 0.00 seconds rather than 0.1 seconds. So this is a brief overview of this new experimental synctest package. You will need to have this experiment. You'll need to give a experimental flag to run the tests, but it works perfectly for now. Maybe in future they will actually make it part of the proper testing suite, and it will no longer be just experimental.